Hello there, and welcome back to another learning series with Mr. Knight. Today's lesson is on carbon compounds. In fact, this lesson is an introduction to organic chemistry. This lesson might be the code for you to understand and master organic chemistry. So I want you to sit back, enjoy this intriguing lesson, and I also want you to participate. So first, let's jump into the uniqueness of carbon atoms. Carbon atom is very unique in terms of drawing and forming organic compounds. And so the first thing I'm going to look at why carbon atoms are so unique is because carbon forms many unique covalent bonds. The second point is that carbon can form 4 total single bonds. Also, carbon can form single bonds between itself and also other nonmetals. The next point is that carbon can form a double bond between itself and other atoms of nonmetals. Carbon can form a triple bond between itself and other atoms of nonmetals. Now let's observe the bonds between carbon. So the bond between carbon atoms, there are only 3 possible bonds, and so they can be a single bond. And a point to note is that a single bond is represented by a single line, which is a representation of a pair of bonding electrons. So within a single bond, there are 2 electrons. So a double bond will be represented by 2 lines, which means 2 pairs of bonding electrons, and also a triple bond, which means 3 lines or 3 pairs of bonding electrons. And so if you do not understand single, double, and triple bond, you can go back to one of my previous videos, which I talk about the types of bond, single, double, and triple bond in covalent compounds. Now we understand the bonds. Let's look at something that is very, very important for you to understand. This is the foundation on which you will stand in terms of understanding organic chemistry to a different level. Now, the first thing I want you to note is that a single carbon atom can form 4 maximum single bonds, which means 4 total lines. So this will be the most, as I said, the most important thing for you to know in moving forward and truly understand how to draw organic compounds. So in simple terms, once you see a carbon atom, there must be 4 lines drawn around each carbon atom. All right? 4 total lines. Now, the combination of the lines may be different, but it does not matter. The combination of the lines, there must be 4 lines. In other words, 4 total single bonds. All right, so let's jump into something else to bring this further and to make this more clearer. Now, let's say you have 2 carbon atoms, single bonded. Then remember the concept that each carbon atom must be represented with what? 4 lines. So there must be 4 lines. So since there is only 1 line around this first carbon, how many more lines are required? Absolutely 3 more lines. Think about this one. There's 1 line around this carbon. How many more lines are required? Remember, the total must be 4, regardless of the combination. So yes, there must be 3 more lines. Beautifully done. Let's look at another example. What about 2 carbon atoms double bonded together? So how many lines can be around each of these carbon atom? And so this first one on the left, there are 2 lines. How many more lines can we place around this one? Absolutely 2 more to make 4 lines. Beautiful. What about this other carbon atom? Yes, there are 2 lines already. So therefore, it can be 2 more lines. Great. Now, if you notice, you'll realize around each carbon, there are 4 lines. And that is the idea. That is the foundation on which you will stand. Now, let's look at another one. Carbon atoms triple bonded together. And so notice there are 3 lines between the carbon atoms. And so this first carbon, there are 3 lines. How many more lines can we have? Absolutely only 1 line. Around this other carbon atom, since there are 3 lines already, how many more lines can we have? 1 more line. Absolutely. So now, if you notice in all these 3 examples, there must be 4 lines around each carbon. So in the chemical sense, there can be 4 maximum single bonds. The combination may be different, but there are 4 lines or 4 total single bonds. Now, let's look at some very important points. And so, very important for you to note is that carbon forms covalent bonds. And that is very unique because carbon will not form ionic bonds but covalent bonds. Now, importantly is that carbon can form bonds with itself and also with other nonmetals. Very important, since we talk about nonmetals, I'm just going to briefly highlight some facts about nonmetals that will help you to travel through this lesson and also to make your organic chemistry experience a wonderful thing. I want you to embrace this concept. And trust me, this will be a lifelong lesson. So, first thing to note is that group 5 elements, they can form a maximum of a triple bond. What this means, around group 5 elements, there must be 3 maximum lines. There can be 3 single bonds, a double bond, and a single bond, or simply a triple bond. But there can only be a maximum of a what? Triple bond. 3 lines. Why is this so? It's because group 5 elements, which are nonmetals, they require 3 more electrons to be satisfied, and each electron gain can be a single bond. So just think about it. Group 5 requires 3 more, can form maximum triple bond. Group 6 elements, they can form a maximum of a what? Double bond. Why is this so? The same concept is that group 6 elements, they require 2 more electrons, and each electron gain could form a single bond. So group 6 elements, they can form 2 single bonds or simply a double bond. Let's look at group 7. Group 7 elements, they can only form single bonds. And why is this so? Because group 7 elements, they have 7 valence electrons and can only take on 1 more electron to form that octet or be totally satisfied. So if you notice the groupings, notice the valence electrons. Group 5 valence electrons require 3 more, 3 triple bond. Group 6 requires 2 more electrons, double bond. Group 7 elements require only 1 more single bond. Very easy. These things are very important for you to understand organic chemistry. Now let's jump into something very, very specific. Now we're going to apply the concepts, all the concepts so far. Now, if you want, you can go back on this lesson and just to refresh your mind before you get into this part, because this part is where we're going to have a ride. Now, let's look at this first example. A carbon to carbon, okay? How many lines are you seeing? Only 1 line, which means it is a single bond. So how many more lines can you place around this carbon on the left? If there's only one, remember it must be 4 lines, so therefore we can put 3 lines. What about this carbon? 1 line is there already, so you can put how many more lines? 3 more lines. And so a carbon to carbon single bond could have 3 other lines around each carbon. Now, importantly, we can supply these single lines with elements that can only form single bond. Hydrogen is very useful in this because hydrogen will only form single bond. In fact, we use hydrogen most times because hydrogen and carbon form what we call hydrocarbons. And so we can complete this structure again with hydrogen. And so this is complete. Now, in future lessons, I will talking about the naming of organic compounds. So you don't need to worry about the names. But right now, your fundamental concept is to make sure you understand how to at least draw organic compounds and why they are drawn in a certain way. And from there, we can do anything. Now, another concept, let's look at these 2 carbon atoms double bonded together. There are 2 lines here. How many more lines can we place on this one? And I guess you're thinking 2 lines. Absolutely. We make 4 lines. Around this other carbon, there are 2 lines. How many more lines can we have? Absolutely 2 more lines. And yes, we can now put on these single bonds elements that can form single bonds. The famous group that I mentioned before that can form single bond is group 7. Hydrogen is in group 1 but also can be placed in group 7. So notice most times it is by itself in the periodic table because it's unique. It has 1 shell and forms single bonds. And so we can put some hydrogen in that one. We can put another hydrogen there. And I'm going to put something different at this end. And I can put any element from group 7, but I'm going to use bromine. And so this is another example of an organic compound. Now, let's look at another example. Let's look at carbon and carbon with the triple bond between them. And so, how many more lines can I place here? Absolutely only 1 line. Awesome job if you're thinking that. What about this carbon? How many more lines can you place there? Only 1 more line. Absolutely. And so we can place hydrogen or any group 7 elements on these single lines. And so let's just put hydrogen for this. All right, so now let us go even deeper. Let's look at this structure. Now notice this carbon has 1 line. So how many more lines you require? And you can think about each of them. And this carbon has 2 lines. How many more lines this one requires? And this one has 3 lines. So how many more lines are required to complete this? So let's look at this carbon first. 1 line requiring 3 more lines. This has 2 lines, so there are 2 more lines needed. And this already has 3 lines around this carbon, so therefore only 1 more line is required. And so we can jump on and put on elements that form single bonds around these lines. And so we could place those with hydrogen. Hydrogen is the most popular one that we'll use most times. And so the second one, yes, we could put a chlorine. Again, is a group 7, and group 7 forms single bonds. And we can put another H, and of course you could put an OH. So this hydroxyl functional group can be placed here because hydroxyl also forms single bond. And so this structure together is an acid. And again, we'll learn how to name these in future lessons. And so this is uniquely done. A double bond here because oxygen can form a double bond. Hydroxide or the hydroxyl group form a single bond. Let's look at another example. Let's look at this one. This one is very interesting. This carbon has 1 line. So how many more lines can we place here? Just think about it. All right, I'm going to come back to that. Nitrogen is in group 5. And I like this part. Nitrogen is in group 5 and therefore means that it has 5 valence electrons, which require 3 more electrons to be completely satisfied. And so it can form a maximum of a triple bond. It could form a single bond and a double bond, or it could form 3 single bonds. And so since there are two lines already, how many more lines can it take on? It can only take on one more line, because remember, group 5 elements can only form a maximum of a triple bond. This carbon, interestingly, has 3 lines right here and 1 line right here. Total 4 lines around this carbon. So think about it. Does this carbon require any more lines? Nitrogen again is in group 5. And remember what group 5 elements they will form. And there are 3 lines around this nitrogen. So think about if it requires any more lines. Let's go to the first carbon and complete this. So remember, 1 line, 4 lines must be around each carbon. So there are 3 more lines. Absolutely. Nitrogen is in group 5, so therefore it can form a maximum of a triple bond, which means only 1 more line is required. This carbon cannot take on any more because it has 4 total lines around it, or 4 total single bonds. The nitrogen is in group 5, so it can form a maximum of a triple bond. So this nitrogen cannot take on anything more. So now we can go and add elements to these. And remember, if there are single lines, you can only add those that can form what? Single lines, or single bond, to be chemically correct. All right. So those are the hydrogen. Again, hydrogen is popular. Right here, we can add hydrogen. We can add anything, a matter of fact, once they can form single bonds. So we're going to add a bromine. And so this is another unique structure. Let's look at another one. And this one is absolutely even more interesting than the first. So look at this one. The carbon, 1 line. So how many more lines can we place around this one? Think about it and see if you could really get it. This nitrogen has 3 lines. Think about it. This carbon has 4 lines, and this nitrogen has 3 lines. So starting with this carbon, since there is only 1 line, we can put how many more lines? We could put 3 lines around that one. This nitrogen has 3 lines, so nothing could be placed there. This carbon has 4 lines, so nothing else could be placed there. This nitrogen has 3 lines, nothing else can be placed there. Let's look at this oxygen. Oxygen is in group 6, so therefore it could form a maximum of a double bond, or at least 2 single bonds. And so if you notice right here, there is a single bond, so therefore there is a need for another bond. And so we can put it right there. So what we can look at now is that we could complete these lines or these bonds by placing hydrogen, and we could put anything right here. It could be hydrogen or it could be something else. So let's put chlorine, for instance, and this is another unique structure. Now the beauty about organic compounds are pretty much endless in terms of how you can draw them, because they are very flexible and unique in the single, double, and triple bonds. So you could draw numerous different types of organic chemistry, theoretically. All right? Let's see. So now, folks, you have seen the possibilities in drawing these structures, and I know you start getting it, and the knock of it at least, to be able to master drawing any organic compounds. And so we're at the end of the lesson, and it was absolutely great to have you here today. I'm looking forward to see you in other lessons, and you can bring a friend. So keep safe until we meet again.